Okay, well, thank you for coming on. As I said, I'm going to start with a little bit of a preamble before we jump into the actual content. Firstly, a thanks to a few people who are not here today to join in the discussion, but who deserve some credit. First of all, we have Marina and Jose, who are some researchers at the Imperial College London, for whom they have developed a case study, which we will count regarding a digital twin of human heart, which I'll talk about as well. And then there's also Calla Westerling, who's a research application manager at the Alan Turing Institute, who was actually the one who put in our team's proposal for this, only then to realise that he was on annual leave celebrating his father's holiday. Don't feel too sorry for him though, because he's currently in sunny Italy. Although he wants to be here, I'm sure he's having a nice time as well. However, in the room and both the virtual and the in-person one, I should also want to say thank you to Sophie, who is also a research application manager at the Alan Turing Institute and will be supporting online and for one of the online facilitation. And then James, who is an SSI fellow, senior research software engineer. I forgot the title now.
A research software engineer.
Research software engineer at the British Antarctic Survey, who has also helped with this mini workshop. And myself, I am Chris. I'm a senior researcher in Trustworthy Systems at the Alan Turing Institute. And I'll say a little bit more about the work through the actual presentation. So to begin, we do have a Slido. That is the QR code or the joining code. So if you do have questions you would like to ask at any point throughout, Sophie will do her best to answer them online if that's how you would like to pose your questions. I'm also very happy, everybody else is, for you people in the room to ask questions. And if there are hands up online, Sophie, that you see where people would like to interrupt, please feel free to, you're welcome to interrupt if there's like clarificatory questions that people would like to raise. But that's the Slido as well, which we will leave some time for at the end of this presentation for discussion and go through. A little bit about this project. So this is a project that we're running at the Alan Turing Institute. It's funded by UKRI's Burr program, which is based at the University of Edinburgh. We are also partnering with the University of York's Centre for Assuring Autonomy and the UK government's Responsible Technology Adoption Unit, which is part of the Department of Science and Innovation and Technology. Now, although the work that we'll be talking about today will likely go beyond the context of digital twins, the current funding that is allowing us to do the work that we're here to showcase and talk about today is focused on how we think about developing trustworthy and ethical digital twins. I'm not going to say too much about digital twins, but for those of you who are unfamiliar with this, largely you can think of a digital twin as a system that in many respects is representing some parts of physical reality, but not only is just doing a standard approach of modeling or simulating, but is trying to connect back to that physical system, whether to control or sort of intervene on it in some sense, hence the idea of this twin. We have a bi-directional flow of data. And so our project is doing some scoping research into what people think about when we think about topics of trustworthy and ethical digital twins. And then we are using this to inform the co-creation of an opening tool, which we'll talk about, as well as some of the practices support that, with the goal of building a multidisciplinary community of practice. So that's the context for why we're here to chat today. QR code, you can snap it there, it will take you to the project page in case you're interested more in digital twins. However, what do we mean by trustworthy and ethical assurance? I, as I said to the discussion group before the break, am a recovering philosopher. So I love definitions, but I appreciate not everybody does. But here is a definition to start the discussion. Trustworthy and ethical assurance is a process of using structured argumentation to clearly demonstrate how a set of claims about some goal of the system are warranted given the available evidence. Again, philosophers love definitions, nobody else does, so let's pick this apart to make it a little bit more actionable for us all. I'm going to focus in on these 4 points, what we mean by structured argumentation and why we think it is a good approach to trustworthy and ethical assurance, and then these properties of a set of claims, goal of the system, and available evidence, and how this facilitates the tool that we're developing. So let's give you an actual example of what we mean when we talk about assurance. This is a very simplified toy model of what we would call an assurance case. Now, assurance in general is just basically how we kind of provide a set of reasons and evidence to build confidence, to build trust. So, for instance, the organisers, I gave them my assurance that I would be here today to sort of lead this mini workshop. I said, yes, I'll be there, I confirm, and then the evidence was me communicating. We give assurance all the time. But when it comes to communicating assurance for complex goals and for complex systems, like if you can't see on the screen here, that an AI system is explainable, it is a lot more than simply saying, yes, I'll be at a mini workshop and here's my email confirming it. What are the set of claims that we need to make, for instance, to first of all justify that something is explainable, and then what are the forms of evidence that we would need to communicate to give that kind of assurance, to build that trust, that not only have we fully understood and communicated what we mean by something like explainability, but that we provided a very transparent, very accessible approach that others can review and evaluate. So let's just walk through this very simple toy example, just so you can get an idea of what it is, what's going on here. So first of all, we have our top level goal, right? This is the main thing we are trying to communicate and assure. I'm trying to, for instance, if I was the one developing this case, trying to convince or communicate or justify another stakeholder, another user, that the AI system that I've developed is explainable. That's the top level goal. Maybe a laudable goal, but in its own not specific enough to be able to justify what it is that I've done to realize that goal. There may be a set of things that I need to do. A couple of examples are as follows. For instance, starting from left to right, if I was maybe developing this AI system to be used in healthcare, maybe I would need to be able to also explain, to justify that the explanations being provided, for instance, by healthcare professionals are actually delivered within that particular context. So trained professionals can indeed explain how that system operates. Very important in healthcare and many other contexts. Maybe I would also need to justify that the model that I've used as part of my AI system is intrinsically interpretable, right? So we have explainability, but we also have interpretability of these algorithms. That's the key part in in terms of justifying explainability. And we may also need to make a claim about the features that were part of this AI system, that they are meaningful within that intended domain. So rather than having a very complex set of features that maybe give high levels of predictive performance to the algorithm, but prevent, say, a healthcare professional from explaining to a patient why some AI system gave the output it did. Instead, we've got some features that actually make sense within the healthcare context. So, for instance, medical features like height or sort of a medical history or sort of the current medications, for instance, how these features fed into an algorithm to derive the relevant results. So here would be a set of claims that I perhaps need to make to be able to justify that goal. Yeah, great.
So just a question to understand it better. Can you maybe discern P1 and P2 a bit more in detail? I didn't get the difference between the two.
So P2 would be something where I'm sort of focusing in on what you could call a technical property of the system. So maybe you'd want to be able to say that because it is quite an important context where explanations are necessary, although we could use something that maybe is not intrinsically interpretable like a neural network, instead we went for a decision tree. And that, for instance, could be enough in the context where the only people using the model were trained data scientists. But actually, when you're in a hospital setting, for instance, in healthcare, it's not just enough that we can extract these kind of interpretations to satisfy our own sort of needs. We also need to be able to communicate and explain it to a patient. So it's a difference between a technical property and that sort of more societal property of being able to give an explanation to another person. So that's the idea here, that it is the trained professional delivering the explanation versus, for instance, the technical property of the algorithm that such an interpretation can be extracted upon which an explanation can be given. Yeah. And then finally, at the very bottom, we have the evidence. So what grounds out the actual argument? So again, it's maybe enough if you all trust the person that you can take their word for it. They've actually gone ahead and done this. But obviously, that's not how the world works. Regulators need to provide see some proof that the actual evidence is sufficient to justify those claims. But people also may be interested in seeing how the evidence was selected, what forms of evidence were selected. So we have the goal, we have these sets of claims, and obviously there are many more than the examples I've given, and then we have the evidence that grounds it. This is the simplest point of what we would call a structured argument, but it is just an argument. Much like a lawyer would stand up in court and give an argument about someone's guilt or innocence, this is just a graphical, structured way of providing them. You don't need to read what's on screen at the moment. All this little video shows is a safety assurance case from Aurora, which is Uber's self-driving, autonomous vehicle division. And the idea here is just to convey that my toy model from the previous slide really is just a toy model. In reality, these types of assurance cases get much, much more complicated when they're used to actually communicate properly, like safety. So, why trustworthy and ethical, and why not just say safety assurance, like has been used for decades in sort of safety critical engineering? Well, it's because if you look towards policymakers and regulators, also many of us are researchers, but research gets picked up in commercial settings and eventually will be put into, say, medical devices or commercial systems. There's a big push at the moment, certainly within the UK, but also internationally, to recognize that AI regulation should not just be about safety, security, or robustness of the model. Of course, these are important technical properties and also societal properties, but we also need to think about ethical properties. So the third point down, which states fairness, is a clear recognition from the Department of Science, Innovation and Technology in the UK that we are thinking about the need to regulate ethical principles as well as, for instance, more kind of technical properties like safety, security, and robustness. And of course, that's just one framework among many across the international space. So this brings us to the tool that we've developed. So what we call the Trustworthy and Ethical Assurance Platform is just a tool to allow people to build assurance cases at partners. This is sort of what we've done. I'll show you in a minute. But it's also supported by what we'd call our Trustworthy and Ethical Assurance Platform, which at the moment it lives on GitHub. It's completely open source. It's publicly available right now. You can go along, you can fork it, you can run it. We've done the usual sort of things of containerizing it so people can run it in their own infrastructure rather than having to just use the public instance that we've created. And what we're now trying to do is develop all of those additional communities of practice, all the sort of skills, training, guidance, to allow this not just to become a hopefully useful tool, but a usable tool, something that people want to use and want to actually contribute back into. And we're not expecting this contribution solely to the development of the web app, the platform, but rather a structured form of knowledge. So one of the key things that we're doing at the moment is building out a repository of assurance cases. And I'll tell you why this is important in a minute. But we're also thinking very carefully about how we integrate with existing pieces of work. So, for instance, standards. This is a big thing in AI regulation and governance at the moment. Organizations like the British Standards Institute, or the ISO, IEEE, a lot of what they do is developing standards that can guide even the ethical governance of an AI system. So we're thinking about how we integrate and sort of connect up to that sort of broader assurance ecosystem. And of course, we are developing open accessible documentation, not just about how to use the tool, but also how to sort of think through and operationalize ethical principles in this context of an assurance case to build skills and training capacity. So let me show you a sort of more concrete demo case. That's the Slido. This is what I actually want to see. So this is our Trustworthy and Ethical Assurance Platform. This is what happens when you log in. You're going to see the cases that you have linked to your profile. Some of these kind of demos that we'll look at in the activity discussion. Others, like this one, are real assurance cases that we've developed with the collaborators at Imperial College London. Now, apologies, obviously the text is going to be too small to see on screen, but I'll read it out and I'm not going to go through every single claim. But let's take this first one here, the goal claim. What this goal claim focuses on is explicitly an ethical property. So we're talking about a digital twin of a human heart here. This is an active research project being developed by researchers at Imperial College London. It's called the CMERGE app. In fact, if I zoom in maybe a little bit, there we go, perhaps you can see a little bit clearer. So this is part of the CMERGE app team, and this is a digital twin that allows people to quantify the scarring of human tissue of the heart to inform clinical diagnosis. And what we've been working on in collaboration with them is developing an assurance case that argues in favor of this goal here. The tool has been designed and developed to ensure fair and equitable use and impact. Now, as you'll see in a minute, some of this requires technical properties, but it is also an ethical goal. And what we've tried to do is break this down into, zoom in, so quickly zoom in on this bit. Okay, I'll just read this out. We tried to focus on 4 key ways of breaking down these claims. So for instance, what we mean by fairness and equity is thinking about how we have demonstrated that bias has been mitigated across the project's life cycle. We're arguing for diversity and inclusivity in the actual project's governance. So again, not just recognizing technical properties as necessary for assuring a goal like this, but also thinking how a project has been governed. Putting claims and evidence forward for the actual impact of the system. So thinking about the consequences that system has, as well as more technical properties like non-discrimination in that particular model's outcomes, which is important in the context of personalized medicine. Now, again, I'm not going to go through every single claim. We actually are about to publish a policy report with this partial assurance case in, but let me just focus on one. So if you think about bias mitigation, there's obviously lots of biases that could be mitigated, but quite an important one in the context of healthcare are the cognitive biases of human operators, healthcare professionals. So one of the claims that we have been looking at with the team is this one. The tool reduces undesirable operator variability to limit the impact of cognitive biases when using the image processing pipeline, the digital twin, as chosen thresholds. What this means is that they have actually carried out, and this is the evidence here, a reproducibility study to show how the particular digital twin brings the decision outcomes made by clinicians into a more tight bound, which means they're less prone to making sort of decisions on the basis of kind of cognitive biases, but instead kind of follow what people would say is the sort of standard best practice approach to medicine into quantifying scarring in this particular instance. And again, you can go through the rest of the assurance case. We could go through it now in a time to see how we're kind of justifying that top level goal and the diversity of the claims that you would need to make to justify something like fairness and equity. But let me move back over to the presentation, and we're going to look at building an assurance case together, by the way, so we're doing the actual interface in a bit more detail. But one of the things I just wanted to draw your attention to in the sort of the final few slides before I hand over to James is what you can do when you bring enough of these assurance cases together. And this is the knowledge sharing part. So let's say, for instance, we go back to that toy model from the start, and we're looking again at explainability. But now we have 2 teams who are trying to use the same structured approach. We have a schema. We're currently sort of standardizing it. We'll be publishing it. It'll be a JSON schema. So there'll be hopefully a very formal standard for what is meant by this trustworthy ethical assurance case. But just looking at these 2 side by side, and again, sorry, you probably won't be able to see the text on the screen. Doesn't matter for the purpose of this. What I wanted to draw attention to instead is that you may have variations. So let's say you've got 2 projects, both focusing on the same goal, but actually they take very different approaches to how they argue for something like explainability or for fairness, or sustainability, whatever it may be. Those differences are really important. First of all, it's a very useful piece of knowledge share, the one that is very structured. So it could be, for instance, they've chosen the same piece of evidence, but used it to justify 2 different claims. That's quite a helpful piece of information to show how best practices are emerging and what they're being used to assure. It could be that you've got 2 identical claims, but different forms of evidence have been used to justify them, or you could have had completely different strategies for developing an assurance case. All of this is useful information for communicating between teams in a very structured and hopefully systematic way. Get enough of them together, and you can generalize across assurance cases to develop what we call argument patterns, which then are structured templates that teams can use to think critically about the work that needs to be done over the course of a project lifecycle to implement trustworthy ethical practices. At which point then the community have created this kind of structured knowledge sharing, which can feed back into the community to provide this very useful standardized templated way for thinking through ethics across a project's lifecycle. So that's kind of what we're trying to sort of focus on at the moment, how we facilitate that sort of structured knowledge share and use it to build best practices that aren't sort of top-down regulation from governments, but ground-up community-driven work and what ethics and responsibility means from within, say, a community of data science scientists, research software engineers, and so on. And with that, I want to hand over to James, who, I've got a question. Yeah, go.
So are you talking to the ICO about this? Because a lot of this overlaps with a lot of what's in GDPR and the DPIA.
Sorry, is it ICO?
Yeah, Information Commission's Office, because there's an awful lot that's in there that covers the data you're working with in the first place. If that bit's right, an awful lot of this is kind of done.
It's very interesting you bring up the ICO because the very first part of this project was an annex from the ICO's explaining AI decisions. So that was a co-led piece of work between the ICO and the Turing. And in Annex 5 was the very first point we put forward this. And so, yes, we have. And that's one of those things where we're trying to complement existing practices, but providing sort of new mechanisms for which this kind of structured knowledge sharing can happen. And on the kind of the data governance, what's quite interesting about that, what that actually can support. So when we think about ethical processes like fairness, some of it actually may fall back upon how we have governed data, how we have adhered, for instance, to legal frameworks like GDPR. So yes, we are in conversation with ITO along with other regulators like MHRA to try and make sure we're not reinventing the wheel, but providing something that is additive back in the community.
Yeah, I used to be an information security officer, but that's why I asked.
Fantastic.
Yeah.
Thank you very much. Over to you, James. And on Burr.
So I'm not a philosopher, and I really about half of what Chris goes on about half the time. So, but no, the reason why I got involved with this, and the reason I have been involved with this, is mainly around the long-term aspirations of what the British Antarctic Survey are trying to do in collaboration with Turing, and that's mainly to look at building environmental digital twins in the long term. Now, in order to do that, I'm a big believer in building via Lego, using Lego brick analogies, building individual components and then having emergent complex systems rise out of them. So very much focus on the idea that digital twins are going to be structurally very thin in the middle. They're going to deal with certain services that will be common amongst all of the components, but then the majority of them will be those components will be fulfilling particular tasks. So in order to do that, you have to then have a sort of information management framework over the top, which is quite a widely recognised sort of approach to governance procedures that might govern these twins. But all of these, talking about fairness, all of these components are going to be interoperable to a greater or lesser extent. But that means they need to be designed with common principles in mind in order to make things interoperable. You can't have a load of heterogeneous components that have been sort of implemented in a freewheeling fashion. And it's when we start to think about that things like the TEDT, the Trustworthy and Ethical Assurance platform become quite important, because we want to take the pain out of offering assurance about those individual components. We want to take the pain of doing that away from the people who might have to implement those projects. With that in mind, the majority of components that I see as part of as sitting within an environmental digital twin or are environmental science related, and they might be research or operational, and they might embody things like uncertainty, which makes assurance quite a difficult thing to approach. So you might think about climate services or forecasting services or other types of models that need to interact with one another in order to provide a function. This all then ties into AI and ML, and as well as process models that we might be running. And it was interesting to hear the generative AI statement this morning about hallucinating components, hallucinating AI. A lot of the claims made in this area are not explicit. So, people will offer up a service and they won't necessarily tell you what claims they're making about the service. They'll just imply that the service can do a useful thing like hallucinate Shakespeare, or in this case, produce output for sea level rise, or maybe the plans for what a ship is going to do over the course of a season. And because a lot of these claims are implicit, I feel that having an awareness, if we're talking about building digital twins, having an awareness that there is an approach to trustworthy and ethical assurance is something that I, as a technologist, need to understand, and I think environmental scientists need to understand. So the reason I've got that picture, or gave that picture to Chris to put up there, is just to understand that a relatively small organisation like British Antarctic Survey and its partners in NERC and more widely, they're relatively small organisations who are not going to spend their time dealing with the kind of questions that Chris and his team are actually looking at in terms of how to approach this. So, we don't have, we might have one information security officer, and that'll be it for the whole organisation, so they're not going to think about this. So, asking the question of whether a system is trustworthy or ethical needs to be something that we can follow a pattern, an assurance pattern with, when we implement the system and potentially operationalise it. So the reason I joined the workshop was mainly to say, well, look, we can have these lofty aspirations around building big digital twins, but ultimately we need to be aware of our responsibilities to ask these questions in the first place, and then we can start building the Lego bricks in a responsible fashion, and that's really important for what we do. So I'm engaged with Chris to learn more, and the team to learn more about this. There are workshops that we're going to be undertaking as part of the TDT project, and hopefully across the entire spectrum of digital twins that the Turing are involved with. You've mentioned the HART application, but there's also the civil engineering applications, as well as the environmental science domain, and no doubt others. If we can share the knowledge of much bigger efforts than with the environmental science community, then that is ultimately going to be a massive time saving. So I think engagement with this at the early stages is quite important. So I've got some reasoning to think on that is possibly just for me, but from the large scale to the small, the points that I take away from being involved with, or at least engaging with a project like this, is that scaling presents challenges to assurance. With all of these individual components, the problems of assurance at a much broader scale is going to become ever more complicated as they interact. The second one is structured approaches are necessary to succeed. They're not an optional, like something that we can approach in an optional fashion. Real world claims should imply that there is assurance carried out as part of the development process. We can't leave it up to an assumed level of assurance when people start, using a climate service to put out information that they might then use in a real world context. And all of this effort underpins sustainable delivery of individual components. So if we're talking about sustainable software and producing it, then we have to make sure that when we design a project, we're actually baking this assurance use case or this assurance framework into what we're doing. So that's my 2 cents worth on approaching it from an environmental science or an environmental digital twin perspective. Thanks for this.
Right, thank you, James. And yeah, you've mentioned obviously the other context of health, but also to say actually the 3 themes we're looking at around in digital twins is natural environment, health, and infrastructure. And it's really important for us that we are sort of testing this out of real world use cases. It's one thing to put out a bunch of principles, whether regulatory, ethical, and technical. It's another thing then to take those principles and put them into practice across a wide range of use cases and see, for instance, how fit for purpose those principles are and the processes by which we operationalize them. So having partners like James and others is very useful and informative, and hopefully both mutual value. Right, why has my computer stopped letting me? Ah, there we go. So now I just want to open up to a very quick Q&A, and just so we're also looking at Slido, and equally offer it up to the room. Maybe I can start with this as I'm looking at. So it's possible that when you combine sugar components together, the resulting construction doesn't meet the requirement. How could that be prevented? So I think the way I'd like to respond to this is to talk about something I haven't yet addressed, which is another reason why we're developing this tool and how we're doing something that's a little bit different to previous assurance tools. So as I mentioned, assurance in this kind of particular structured way is not new. It's been around for decades, but it's mostly being used within safety critical domains like engineering and largely focusing on goals like safety, not only, but largely. And one of the reasons for that is it's often an important form of compliance or conformity assessment. But when you do compliance and conformity assessment, the tendency is to leave it until the very end, and then once you've got the ticks, to go, yeah, it's all good, not think about it again. What we're trying to highlight here, and we'll look at in the activity, is why it's important to begin these conversations very early on, why it requires multi-stakeholder engagement across a project's lifecycle to do well, and why the evaluation of an assurance case, especially when dealing with intellectual properties, really ought to be an open, collaborative practice, and it's the reason we're in a collaborations workshop. And so this question, why, when it doesn't meet the requirements, how could that be prevented? I would sort of fall back on the cliche of light being the best disinfectant, that what we're trying to do, and this is a feature we haven't yet built into the platform, but we're currently looking at how to do, is how you enable good forms of dialogue and more open deliberation. So that, for instance, if I put forward a claim and a piece of evidence that the community don't accept, that can be a useful to try and strengthen an overarching kind of assurance case. But it requires that kind of tooling to be very usable, very open and supporting collaboration. So that's a good response I'd give. But I don't know if James or Sophie, you want to respond to that?
No, the only thing I would say on that is that this is why there is such a level of complexity as soon as you start stitching things together, and you have to look at the real world use case of what you're going to offer up. And this is why I think it's quite interesting to start with the Lego bricks rather than like, you have to have that underlying pattern in order for the complex system.
The question was more that, you can have perfectly good individual Lego bricks, but when you put them together, the resulting thing is not a good thing.
But if you identify this is why I would say, if you identify the use case of what you're going to, then you have to assure the use case, if that makes sense.
I just worry that some people may go, well, all the components are fine, therefore the resulting thing is fine, when actually the resulting thing isn't fine.
It's one of the reasons we want to engage philosophers. Philosophers have done a lot of thinking about sort of how you structure sort of a formal approach to reasoning, and where you can't make assumptions, for instance, about, say, independence of claims and strength of the evidence, because they may not be independent and there may be all these complexities. That's why also we really want this to be a very multidisciplinary research project, and why places like this are so good, because it is such a mixture of backgrounds. But yeah, it's a very valid point. We're going to encounter blocks and barriers, I'm sure, but I think we've certainly found at least a hopefully promising route forward to address some of these concerns, even if it ends up being imperfect. Any other questions from the room before we move to the activity?
I think there's a question on the
Yes, there's a question in the online chat. Do you want to read it out, or do you want me to read it out? It's not on Slido, but I'll just read it out. It's here in the Zoom chat. So Caitlin is asking, any thoughts on thinking about timescales and or emergence of behaviors over time? And she specifies that this question is about transitions as professionals or organizations and operations gain experience.
Caitlin, are you willing to say a little bit more about that question, so I make sure that it's...
Yeah, no, like I'm just curious to understand if you have been thinking about how to represent such dynamics in a static assurance case, but also as we know that that it is a concern about AI and how it can degrade over time, or like which periods or intervals do we need to be redoing the assurance case or anything. Like, I think it also relates to this idea of where you're not just looking at the components, but rather also thinking more holistically about the system or a use case, as you pointed out. But I just wondered how you could represent or think about those things using your tool.
Good, thank you. So I just wanted to clarify the sort of the notion of emergence that you wanted to draw attention to, because there's emergence over time, which is interesting, like how good is an assurance case in 1 month, 6 months, and a year, versus the sort of another concern, which is, are you assuring a property of a system, or are you assuring the use of that system within a particular environment? Which, again, to go back to the healthcare example, is particularly challenging, because developers may be producing tools which will only be used in novel ways for which the assurance is not actually sufficient. That's a big problem then when you're procuring services which, for instance, haven't been designed for the context you're deploying them in. A big issue we've had with we've just discussed with regulators, where the remit of regulators also isn't set up particularly well for this. One element that I didn't talk about in the toy model, but is also within an assurance case, and I didn't want to go into all the elements to avoid some complexity due to time, is actually there is something called a context claim, which is where you specifically provide the context for your assurance. And that's almost like the limitations section of a paper. You're saying, we're assuring some property of a system or a project, but only when it's used within this system. So to lean on a very traditional example, you can assure, for instance, the safety of an airplane component, but only when it's operated by trained pilots. You're not assuring a plane to be flown by anybody, right? So there's always constraints to an assurance case. And a context claim is where you make those constraints very, very explicit so that you're kind of addressing some of those trickier questions around emergence. It then becomes a very open question, I think, to how far you can go with the scope of your assurance, but without the use cases that James mentioned, I don't think I could say anything more than a very, very specific project example.
Do you also then need to be explicit on the data? Because, you know, there are massive issues in healthcare and issues in data. And obviously there's very little data on women in healthcare because all the studies were done on men. So with this, I mean, there's massive issues around heart disease, for instance, because they're very different. So would you explicitly put in here that actually the majority of the training data was by its nature on that, and then that has a impact on the
So
outcome?
this was the big challenge we actually had with the team in Imperial, and what is quite, we're tweaking the UI at the moment, and actually, if I had been able to give this presentation in 2 weeks' time, it would be an entirely different UI, but we haven't merged it into the main branch yet. But eventually, you'll have little bits of feedback that show when a claim has not been evidenced. But this is actually one of those claims where they want to be able to make this claim, but they can't for all those reasons, where they actually don't have sufficient data to be confident because of the representativeness or missingness in their data set to make the claim. The tool does not discriminate across different patient groups and ensures quality and consistency of results. For that very reason, they actually don't have access to the data. But this is again why we're not putting this forward as a tool for compliance, but actually as a useful tool for researchers, because they can think about the claims they would like to make, and then they can see where those gaps are, and then think about what they need to do over the course of a research project to address them. And it may be that they can't, for all the reasons that have just been mentioned, but that can be a very useful thing for the community to also know about, that this is a claim that as a community we want to better make, but we can't get the data, we don't have reliable techniques, there's actually no good way of verifying or validating this. And that can be a useful thing to feed back in, and people can develop new tools to help address those research questions, which is why we don't want this just to be a regulation or a compliance tool. We really want this to be something that can support research and best practice development. I'll come to this question, I think we should probably move to the activity, but I think you had your hand up.
Yeah, sorry, I keep adding to the ideas.
The activity is just to facilitate discussion, so if we're having discussion now, then.
Well, maybe that's it. I was going to say, like, given that you have to have these a specific area in which these tools are used, how do you feel about LLM being out in the public? Don't really have that.
How do I feel?
Do you think that OpenAI needs more philosophers?
My old research assistant just went to work at OpenAI. I have very strong views on this. Whether or not people can change organizations from within, I don't know. I think that'll get very political very quickly. No, sorry, but I'll say there's an important part to that question. I think we also just have to address the fact that they're here now, and we have to try and, it's like climate change as well. Like we were in Australia recently, Sophie and I. They're not thinking about prevention anymore, they're thinking about mitigation. And I think probably we need to be doing the same thing. Like they're here, we've kind of failed to sort of prevent them as a society, largely because of key actors. What can we now do to mitigate additional harms? I think it's unfortunately the position we're in. It'd be lovely if people thought about stuff in advance, but nothing was happening. Let me introduce the activity, and hopefully we've got enough time just for you all to kind of get into the actual mindset of putting an insurance case together. So to that end, myself and Sophie are going to sort of split the kind of the rooms up now. So we'll have the online and the in-person. There's a big split in the numbers. We were sort of maybe hoping that there was a bit more of an even balance, but that's fine. We have two fictional projects. So in the room, we're all going to be pretending now that we're Uber or some company creating an autonomous vehicle. And we're going to think through what sort of claims and evidence we would like to be able to make about a particular goal for this company. And Sophie is going to be doing something very similar, but it's going to be looking at another fictional case study involving autonomous facial recognition. And what we want to do is quite simple. We're going to provide a goal claim for you all in a minute. I'll show you what that'll be for us. And then we just want to open up the room to discussion to think, what are the sorts of claims that you think we would need to make if we wanted to try and assure that goal? And then once we have maybe 2 or 3 claims, we're not going to have enough time to do also the full assurance case. What are the sorts of evidence that we would want to bring forward to try and actually validate and provide enough justification that those claims have indeed been realised within the project? And my Mac is about to die of battery, so I'm going to plug in, maybe while I let the online room split off and mute themselves. And obviously, Sophie, you then can provide the sort of specifics about your goal claim and anything else more about the case study. And I will do the same for our group in 2 seconds.
Right, I will create a breakout room and just assign anyone I see online to join.
I don't think we're going to come back to plenary for time's sake to share out, but we will stop at the time just so the online know to come back.
Okay.
So here. Here is the assurance case we're going to be working from. So we are going to think about safety. Oh, that's not the right one. So I've been building too many demo cases. This is the one, SSI workshop. Okay. So here's the goal claim that we've set. So we're not going to be thinking about the whole vehicle. We're actually just going to focus on a very specific component. And the goal that we are trying to sort of target and aim for in this kind of fictional project that we're all involved in is that the object detection and avoidance system is designed and operated to minimize bias and ensure equitable treatment for all people. Now, one thing you may want to do is pick apart that goal claim, and that's an important part of an assurance process, that you actually refine the goal as you kind of understand the project. But this is our starting point, so I'd like to open it up to you. What sort of claims or actions do you think you would need to take over the course of this project, building this kind of object detection system within an autonomous vehicle, to be confident that we have designed it and deployed it in a way that minimizes bias and ensures equitable treatment for all people were it to be deployed in the road? Anybody want to kick us off with a proposal for a claim we want to make?
Not a proposal, but is there any chance you can make that text for our bigger eight a bit bigger?
If I had the new UI, yes, I can try and zoom in a little bit. As I'm sure many of the software research engineers in the room will appreciate, we did a big overhaul moving from to Next.js and Tailwind, and it wasn't ready to merge, I'm afraid. So this is the UI we have. Hopefully you can see that clearly now. Basically, this box here is saying what it says in the actual app.
So my question's around the aim really.
Mhm.
So is it talking about that basically it equally tries not to hit you regardless of physical size, age, gender, ethnicity? Like, is that kind of,
A great starting point, yes, let's go with that.
because there's lots of light issues with that, and we know that people recognition is bad currently.
So how would we kind of sort of convert that concern into a sort of a positive proposal that we then want to try and actually go, right, that's the claim we want to be able to make, what are we going to need to do to actually be confident that we've made it?
Identifying everybody, regardless of skin tone, in all light conditions.
So all people can be accurately, I'm going to have to sort of just put what you said in.
But that's kind of the first.
Accurately identified regardless of lighting conditions.
Yes.
Cool. Now, it may be hard for us to identify the exact evidence unless people actually are building autonomous vehicles. But one thing I want to highlight is that assurance cases notoriously are pretty difficult to make. The way we have created this platform is actually to abstract away the requirements for the user to know everything about assurance. So the only options we can provide in this tool are basically consistent with the underlying schema and its logic. So we're trying to make it really usable. You don't have to know the standard. You don't have to know, for instance, that only a property claim can be the parent of an evidence or another claim. We've taken that logic out of the decision-making process. I'll just flag, for instance, that if I went back to the gold claim, you'll notice there will be other options. So we're making a much more useful tool than traditionally has been happening in insurance. So we can add a piece of evidence, and I don't really want us to try and put forward a piece of evidence that would convince others that all people can be accurately identified regardless of lighting conditions.
Evidence for a trial, I imagine.
Sure. So maybe some sort of,
Like a peer review trial, ideally.
that'd be like,
You need to do a street trial though, because lab conditions are very different to real world lighting and artificial light. And that really messes with the sensors.
I would like to try and focus rather than on getting on this like perfectly kind of correct for the engineering context, to more focus on the claim. So let's just say we have some trial, and it may also be that we needed multiple forms of evidence. Again, the platform supports that. So you could come back and you could add a second piece of evidence, and fortunately the layout algorithm will take care of the messy parts of doing that. But let's move on to a second claim. Does anyone else want to put anything else out there? So just a reminder.
Try to set some bounds to help me understand
Sure.
the kind of remit or this object avoidance system, and are we getting into trolley problem? Is that in the scope of this fictional system?
Because we're right at the beginning of the
Trust
project. We're right at the beginning of the project, and we're opening this up to kind of critical reflection and deliberation. So do you have a thought about a concern?
I guess it's about, this is quite challenging, I'm finding it's quite challenging, but I guess it's about making choices over rerouting or redirecting the vehicle based on the available information. That's kind of what we're getting into.
So is the concern that if it does have to steer away from maybe one person, but the consequence of doing that is it'll hit another, that it's making those decisions in a way that would be fair? Like that,
There's another one about whether or not it's prioritising the life of the person.
Famously, it's on the problem.
That's one.
And you take into account the number of people in the car versus the number of people it could potentially hit.
Second,
As
sorry.
well.
This is about recognition, I think, so it's not about making decisions.
I think that's what I was trying to.
Would that be part of that? Or-
Well, so actually, I have included avoidance system, so the object detection and avoidance system. Now, whether or not you would actually bring those two together, I don't make autonomous vehicles, so I'm sorry, I'm misconveying something, how these systems would work. You may, as you say, Lena, just want to focus solely on the object detection thing. This is just a classification task. We're not talking about the collision decisions and how those may be prioritized. Perhaps I would give rise, but for the sake of this fictional case study, let's do ranks. This brings up some interesting philosophical blends. So the
evidence, it conveys a panel of philosophers.
It says equitable, but do you want equitable weighting? I mean, do you want like is a pregnant person more valuable than a non-pregnant person and things like that?
It's off the room.
Or an argument might be it puts it under human control when it can't decide.
Yeah.
So I would say in those situations, it's actually the base rate would be really important. So what's the likelihood of actually encountering different types of people? So if the base rates aren't equal, we probably shouldn't have equal weighting for the actual case. This is very important also in like criminal justice, for instance. Men are a lot more violent. So if we're going to be developing a prediction system about the likelihood of committing crime, we don't want to treat men and women the same. Men commit more crimes. So you don't want to treat those kind of groups fairly. Same in medicine. The disposition for certain demographics to experience certain health outcomes is also not equal. So the actual weighting of people may actually depend on who is going to be encountered on the street. Because if cyclists are more likely to be encountered, then prioritize them than, for instance, babies walking around. If you don't expect to see a baby crossing the street.
No, I just think of it, but then if you've got an environmental context, if the car knows that it's near a school, for instance, does that give it a slightly different weighting potentially because it knows it's going to be an awful lot more small children about?
Essentially simplify or maybe cause more problems in the children. But actually, like the avoidance problem is kind of slightly solved if you take into account the probability that in avoiding you're going to create another accident that you won't foresee. So you can't be assured that you would actually successfully avoid. You can only make a good attempt, at which point the base answer is actually just to do nothing at all and accept the fact you're already in an accident situation. So the part avoidance thing is really hard.
Yeah,
I'm not
that's
sure
what
about how.
if you slam on the brakes, you cause more problems than if you didn't.
Yeah,
I guess one big thing from that is that it would be timely, like, it's going to be a heuristic decision, but, you know, it needs to be timely. It's only got a limited amount of time to react, so an assurance would need to be, there needs to be, you know, a quality assured time response to anything that it's going to do.
so this is nice one, because, and I want to try and show how this sort of process and sort of also kind of is meant to facilitate this discussion, because again, recovering philosopher, I love tangents and exploring these conversations, but when you're in a practical scenario, you need to be able to kind of like connect this up to a sort of an actionable way forward. So what we're trying to do here is also create a structure where people can do this kind of drafting, and then in this kind of discussions, they recognize there are problems. We're like, okay, you know what, that equitable weighting thing, that's hard. We're going to place that there. We know that's some sort of claim we need to make, but we don't quite know how to specify it or what evidence we need to be identifying. Likewise, this decisions are timely. That's actually quite an important sub-property of maybe a claim you want to be making about how the collision decisions are even made. So what we can do is we can nest claims within others. This does bring back the same problem you mentioned about how this kind of the assurance of individual claims connects up to a larger thing, but we're trying to figure out a formal way to sort of figure that out. At the moment, the user interface just provides the way to structure the argument as a kind of decomposed set of claims or Lego blocks, as James mentioned. So what I've done here is I've placed this decisions are timely property, how do we formulate it, as a subclaim to collision decisions. I think there are two hands up on this side. Is that right?
I mean, I don't know, I've talked for a few other people, so if anyone wants to go ahead.
Yeah, I want to bring back us to a different, if you can open the ball, I want to focus on the operation side a little bit, because it also says operated, designed and operated, and I was wondering how can we claim about the transparency of operation, and I don't know how to word it, but I believe a claim should be made that the operation of this object detection and avoidance system should be transparent, and it should be transparent to the users, to the drivers, or for other third parties that wants to assure or maybe insure the car itself, or for the third party. So
this is a nice one, and I specifically included the term in this one around the operation sort of to maybe please any human factors or HCI people that would be in the room, because I think it's an important part around acknowledging you will have to address societal issues around governance, technical properties, how you mitigate formal bias, as well as human factors of what actually is going to happen when this is deployed in real life. And I think something around the system behavior being transparent to users is very nice. Can I ask, what sort of evidence would satisfy you that had been, if that kind of goal in precisely claimed has been realised? What sort of evidence could we bring to bear on justifying a claim like that? Either.
Making sure the training data is available, anonymized to protect participants, but available so everyone can see the source data and understand and verify it.
Right, so,
One key decision to of some sort, yeah.
how about, so there's a question here I think you would probably want to raise, like how much can we make available? So perhaps you want to push back and say some form of documentation, but who is it being communicated to? Maybe there are concerns around IP. This is something where, again, the exact nature of the claim would really need to fit the actual context of the project. But it's, and although, are the users going to want to pour over a bunch of training data or a model card? Probably not.
I think assurance about spread of things like diversity and the types. So basically, even if it was just statistics on the types of data it was trained on to show that there was variation in data diversity within that.
So here again is where we perhaps want to make a